we may so I was explaining about this building block of brain. So some part of this is called dendroid. So it takes the information and it process it, and this same way of taking information and processing it and giving output or information is processed information is make forward after making some decision. So one side of hand, if I pinch, it directly goes to brain. It will not go for leg and other hands. So bytes will be there. Other informations will be passes very fastly.
I request participant to mute their mic. Or all participants, please mute your mic.
Okay. So yeah, coming to what is same how we pretend the same neuron in artificial neural networks. This information is processed and processed with the activation function and required bias and processed to other neurons. So in details, I will explain everything. So basically, the basic structure of neuron is in this way. It takes the information, it's added some bias, some constant parameter, and activate it, and it process it based on the weights and this one, and give the output information to other input information to other neuron. Okay, then same way. So this how the artificial neural network is get trained. This is very important here practically in real life. So we take the information and we process it and we learn our model, make it learn our model, and then we predict. This is a very simple way of expressing any AI model. So how it, there are steps involved in this. There are multiple steps. As we are not going deeper in the theory part, it has sub sections like in data processing. There are multiple processings. How many data need to be taken? What type of data need to be collected? Is that data is relevant to that business model? And here, what are the training process? Which are the training process? Data is balanced or not? There are multiple theory parts, but I took to understanding some superficial terms to understand that basically what's happening in the training process. And once training is done, then we validate it and test for the real scenario. What are the things here? It get initiated, weights are getting initialization, and there is a process called forward propagation and backward propagation and regularization. Regularization is very important because at a certain point we have to stop our training, and we have to see that it should not be overfitted. Then hyperparameter tuning. There are parameters which are need to be tuned according to our business scenario and according to our data set. So I kept here one sentence, a paragraph, which is very important during our training. Training deep neural network is a complex process. I did here complex process because see, you can imagine that to pretend to learn equation of a given image or given input data, it has to learn, it has to adjust the weights, and it has to understand the pattern. So doing doing so, it needs computational resources, a lot of very big computational resources, need to understand the hardware capabilities. So based on the, if 1 million data set is there and you are running on a laptop or a simple 64 GB RAM data set, then RAM computer, then that data set won't be giving good results, and it will not be effective. See, here complex process in the sense, see, you need to learn, you need to make your model to learn in a very very good architecture. Architecture in the sense, I am going to tell that what is these complex processes are there, okay, in detail. Now, and preparation and experimentation. See, experimentation, here a lot of requirement is there, because see, sometimes we thought that this data set is enough to go with the prediction. We after doing, after one experiments, we got to know that it is not behaving, model is not behaving as per our business scenario. So we need to go it and prepare the data set properly. This is called experiments. Okay, so we will get the this process, try and error. This process will continue. Okay, till we achieve the business scenario. Business scenario might be detection of a face from the in a office. In an office, one person is coming to for attendance purpose. So then it has to be detected properly. So it has to be detected in different scenarios. Like he might be wearing specs one day he might be wearing only lens, or he might he have beer and one day come without shave. He came with shaving. So that all scenario need to be taken care. Then it has to train, model need to train and experiment. Then it will be go for production. So that preparation and experimentation is very very necessary for any production model. Production model in the sense, see, if we are going in live, or we are AI model is putting in live to detect, that is called production model. Okay, so here, state of art. What is the state of art? It is very important here, and we are also working on state of art here. See, we need not to start from scratch to writing an architecture of a neural network, and again training with 1 millions of 10 millions of data set, and start with our scenario. Now, these models are already in the market, GitHubs and model. They have done for this. Then we can take that weights and start with training with our data set. See, suppose now today I'm training for some my face. I want to detect my face whenever I'm crossing this street. So that time, I need not to start with from scratch. I will take the weighted, calculated weights and train for that my face again for a few images, and proceed for deployment. That is called state of art. Okay, this today we are doing with this only. So we will be taking already trained model, and we are running for few scenarios of our own. Then we are predicting our own scenarios. Okay. So here, as we see that training process, here I want to proceed. I want to give one glance of data proportion. So there is something called data augmentation. There are multiple here, but this is very most important, and everybody does this during this process. So what is this? In this, for one single image, what we are doing, this is the original image. We are flipping it. Okay, we are flipping, we are rotating. I mean, why we are doing? Because that single image makes us to have options of multiple things. For example, here it is randomly cropped. I took only one. There are multiple crops here, and making noise. Noise is blurring. Okay, making blur, and here patches are given. Okay. Patches is given because this is sometime what happened in the real scenario. This area might be covered with something else. So model is supposed to know, even though something else is there, this is a teddy bear kind of thing. Okay. What is this? And say here, one more thing is, if your context changing means increasing, decreasing, there are multiple scenarios, like we decrease the contracts and we make it dark. We will make it very white, very bright, so that model will learn this type of situation of this one image, and it will get if in real scenario when it comes night, it should detect. Okay, teddy bear with a book kind of thing. Okay, we will go ahead because so yeah. So this is basic neural network. These are the information from taken from the image, that image, and this is pixels. Actually, pixels. See, this T is written, right? This T is written. It's nothing but
मी काल शाळेत गेलते का तू आजारी पडली मग मी घरीच होते मला
I
मॅडम
think
किती
someone has to mute.
शाळेत नाही आल्या तुम्ही का?
Yes, please unmute yourself. Mute yourself, please. Participant, please mute yourself.
Yeah. So what I was telling that this is a pixel. Like here, T is written with some pixels. So these pixels is taken as round here for representation. This information is fed to next neural. This is neural network, one what we call as neuron. So it take the information here, and it process, and weight is adjusted, and it gives here, gives to this here, and takes from this information, and process and give the output. Finally, this is forward propagation and backward propagation. It comes back also. Information goes back. The brain has to take the order and give the order, give the instructions as well. So I made only one slide, but this is very vast subject. I can say that whole day we can spend on these two topic only. But the basic scenario is take the information on, also give the instructions back. Okay, by adjusting weights. So we will go ahead. So regularization, what I was telling before, it's a there are two steps. There are multiple steps, majorly two steps. We will make we regulate the model. See, some architecture need to be regulate. Like here, it is there, but we are not taking. We are dropping this neurons. Sometime we will drop the whole layer. Only one neuron is active, and other are totally hidden, kind of thing. And early stopping, it should not divert our training process and validation process. So we have to stop here only. Okay. So there are regulation techniques. Okay. So what is convolution? Now we will go ahead with CNN, convolution neural network. What is it? It is very good design, well designed. In neural network, we start with the ANN, then CNN, then RNN, then multiple advanced techniques are there. So ANN, this was the ANN, this was the ANN. Now CNN, CNN. See, you for any single image, we can divide it into three. That is RGB. Red, blue, green. Okay, green and blue. So I took, for example, to show just an image. So, and this is the pixel value, where the pixel value start with the 0 to 256, and 0 represent black, and the other colors, it goes like that. So some values is there, see, in grayscale like that. So now here you can see that some value of this green, the value of blue is added, it will become some other color kind of thing. And if we see this, if we combine this, we will get some C shape picture. So here I want to show this. Is possible? Yeah. So this is the convolutional is happening. We are taking the information of image in a small filter. This is called convolutional. Okay, it will restart again. See, this takes the information, this takes the information, and this filter is the yellow color. It has the number of filters in the market. We take that filter, designed for specific purpose, and we will convolute, and again we will go for next process. Okay, the next process also I wrote here. This is the real scenario. This is our filter. This is our filter. I'm applying to this image, and this image is slides over one by one. This sliding also, we have a lot of theory behind that. Jumping only one step, jumping many steps, skipping one step. This is called padding. Padding is required or not required. There are multiple theory. As we go on, we can understand, or I will give the link to you read from that. So this information is taken, and it's put in a different image. Okay. So we will proceed. See, I was telling some activation functions. There are multiple activation functions. There are many activation functions, but for now, I took only 2 for our this lecture purpose. One is ReLU. This activation function, what it does is, whatever negative is there, it makes 0, and whatever positive is there, it takes positive, that value itself. Okay, and here also there are many subvariant like leaky ReLUs are there. We will not go deep in that. Simple scenario is whatever negative is there, it will take that 0 only, and whatever positive is there, that it takes value. Softmax function is we use usually to get probability of that class classification. Say here we can see that this class is more dominated, and we will take this probability. This is based on the softmax function. So now one more thing I want to show. There are some parameters you need to understand in the convolutional neural network. See, this information is carrying on. This is the image, original image. This image is given to this is a filter, this moving filter. And this filter applied to here, this is called capturing the maximum pool, max pool, and it will take this information. So if we go here, we will get this, how it will be proceed. This is a filter unit, and we pass that filter unit. We take this information. This is the triangle image. This triangle image is fed to this way. So others are 0, and this information is fed to our model. See, you can see that 256, 255 it is written here, and here it's 0, because no, see here our information is this only. Okay, main concentration on that information, and that information fed to the model, and model will understand that pattern. Okay, we will go ahead. See, there is one more concept called pooling. There are 2 types of pooling: max pooling and average pooling. So in max pooling, the information is pull. See here, what is the maximum? This one it takes here. What is the maximum? It takes here. Maximum it takes that here average. So why we are doing this? You can imagine that the major information from here is this only. It carries this only. So it will get can. I will explain in detail. You will understand in next slide. See this here. This is the basic architecture of a CNN. See, this architecture maybe changes for model to model. You can come up with a new model. You can design your own architecture in this way. This is an image of three layers. This image is fed to the convolutional plus ReLU function. See, this information, convolutional, you got to know that this information is, it's a image only, but reduced form. Only this major information